Number 4. You have x8 and x minus 3. But then it wouldn't expand out to this, would it be? Because if you had x plus 8 and x minus 3, you'd end up with x squared minus plus 5x minus 24. Right? So what my guess is you forgot to do that part. The 3 would slide forward and that would become 1. Or the way you do yours, you would have had, doing decomposition. Yeah, I don't know how. Okay, yeah. So you were doing the slide and divide there? But you do prefer decomposition, yes? Okay. Let's see. There for 2. There for 1. Oh, I've made a horrible mess of number 9. But number 9 is 6x minus 1 and 2x minus 1. Ah! Highlight. And that's a 1. That's a 1. And those are both 1s because you're just running it through the cube formula. Making that row out of 2. Oh, I have that right there, out of 2. Anybody need to ask about any of those? Once going, twice going, thrice. About which? Yes? Because you can't factor a sum of squares. You can only factor a difference of squares. Because if you do a sum, there's no way you can multiply to get a positive and have the middle term disappear, right? And there's 13 and 14, both for 1 each. Making the first page out of 18. Total up your stuff, please. And again, ladies and gentlemen, I cannot stress this enough. If you lie on these, and you lie on your quizzes, and you get 5 out of 80 on the test, that does not bode well for you, right? Your test scores should be within 10% of your quizzes and assignment scores. Unless you're coming in for a lot extra help, then I would expect to see a big jump, right? What I should never see is the precipitous drop that I see from a great many students, right? There's no reason to get 96% on this and 20% on your test. And you laugh, Jacqueline, but that is a pretty normal spread with a lot of people. And they will say to me, oh, it's because I have my notes and everything when I do my quizzes or when I do my assignments. And say, yeah, that may be true, but a 70% drop, that seems odd. Especially when I put the exact same questions on the tests that are in the notes, very often. Like down to the same variable even.
Can you stop for 1 second just so I can see which questions are with how much, please?
Sure. How much further up do I need to go? The bottom ones are all 1 because they were 1-steppers, right? The whole bottom 6 were 1 because they were only 1-steppers. 9 through 14 are 1-steppers. So they're all worth 1. I will accept, of course, both of those answers there. And that is the final answer there. But number 16 is a giant mess. So I don't mind going over 16, because a lot of you still don't seem to understand this move. And I'm really at a loss to explain or to try and understand why this move is complicated for a lot of you. I need you to be honest. I know that if you broadcasting that you don't understand something feels wrong to you. I get that. But I need to know, how many of you do not understand this move? What I am doing here? Like, be honest. Yeah, but I don't believe that only 3 hands need to go up. I believe there are more people that do not understand what I am doing here. Only 3 hands? Yeah, you're one of them. Okay, so let's just take a moment here and once again ask, how many of you can factor that in your head right now? Should be every single one of you, right? That's x plus 3 and x minus 3, right? All of you can do that, yes? Okay, now x equals 4. Can you tell me what this answer is now? What is it? 7. Can you tell me what the answer is if you went down here? What would this become? 7 times, what would this become? 1. Can everybody follow what I've drawn in black here? Okay, so you all knew that when you saw x equaled 4, you would put 4 everywhere you saw an x, yes? Everyone agrees? Okay, so now I'm going to give you this question, but I'm not going to make it a difference of sum of cubes. I'll make it a regular one, okay? Just a difference of squares. Now this bothers a great many of you. You say it doesn't, but I mark your work. And no matter how many times I show you the easy way to do it, most of you are expanding this. Now watch. M equals x plus 2. Now, when I told you x was 7, you put 7 in for every x, yes? So what am I telling you here in red? What does this mean? What does this say in English? M is x plus 2, right? What do you see right there? X plus 2. What does x plus 2 equal? M. Everybody okay with that? So I substitute that. Is everybody good? M is x plus 2, yes? Now, how do you factor that? We just did it literally 5 seconds ago. What is this? M plus 3 and M minus 3, yes? Okay. What is M? X plus 2 plus 3. In the 9th grade, what would you do with that expression? X plus 2 plus 3. What would you do? How? You would collect the like terms, yes? X plus 5. M is what? X plus 2 minus 3. What would you do with that? To get what? X minus 1. That's all you're doing. It doesn't matter how complicated it gets. See, over here, I made this M. And now I just ran it through the formula, right? The cube root of the first one, M, the cube root of that. Then the first one squared, then the first one times the second one, right? right? And I got to m is x plus 2, right? Well, there's an m, so I made it x plus 2. Plus 2. X plus 4 out front. In here, x plus 2 squared, which became, and I wrote it right here, x squared plus 4x plus 4, minus 2m, which was x plus 2, which got me negative 2x minus 4, and then I just collected my like terms. Everybody cool? I mean, really, this move that I'm showing you here in the 11th grade is no different than what you've done since the first day you started doing algebra in grade 6. I lie. The first day you did algebra was the first day you did math in kindergarten. Your teacher just didn't call it algebra. They didn't start calling it algebra until grade 8 when they could scare you with the word. Algebra is kind of like Voldemort. If they'd been saying it from the beginning, nobody would have been scared of him. But since algebra is the math that must not be named, we get in trouble. And that makes the back page out of 1, 2, and 5. 5 and 18 gives me 23.
You didn't show us the last one.
Is there one that I missed? Where's 17? Oh, right there. Yeah. All right. So again, we have a number at the front that we cannot get rid of, right? So there's lots of methods. If you're a guessy, checky person, keep doing that. I don't like it. I don't want to do it because it's not the way I was ever taught to do it, and it takes me a long time to do guessy, checky. So I don't want to do it. Everybody cool? So I'm only going to show you one of the other methods because they all work out the same. They all start with this. This is 12 times bigger than 1, so I have to multiply by 12 across here. So I need to multiply to 12 and add to negative 8. And it, of course, is negative 6 and negative 2, right? Now, here is where the 3 methods start. First method, in red, you can do this. 12x squared minus 6x minus 2x plus 1. That gives you these two groups, yes? Factor that, 6x, leaving you with 2x minus 1. Anything factor out of there? Anything factor out of there? 1, right? So minus 1, 2x minus 1, right? Now, 6x minus 1, this one, and 2x minus 1, this one. That is called decomposition. That is the way I was taught to factor. That is the way most every old grown-up, if you still know a grown-up that knows how to do this, that's what they do. If you Google factoring these, I think the majority of the beginning, the first few you find will show you this method. That's cool. It's just practice, right? You know what you're doing. We just need practice. The second method, the one I learned because this scared kids. Same thing, it's 6 and 2. So I do x plus, not plus, you idiot, minus 6, x minus 2. But the only reason I know it's 6 and 2 is because I multiplied by 12. So I got to get rid of that 12. Then I simplify every fraction. 1 over 2, 1 over 6. And the denominators slide to the front. Now, I've already shown you why the denominator slides to the front. So because I've shown you why, I'm only showing you what to do now. 2x minus 1, 6x minus 1. And the third method I learned starts the same way. Now, I don't like this method very much. I just learned it last year. I don't like it because there's something you do here that you don't do any other time, and it confuses kids sometimes. And that is you keep the 12x squared minus 6 and the 12x minus 6 and the, oh man, I'm screwing this up now myself. 12x minus 6 and 12x minus 2. You keep the 12x and you put your two factors there. Then this is the part I don't like. You factor these. Now, normally when we GCF, we have to keep these factors, don't we? But in this method, we don't keep those factors, which is why it's confusing. So if you're only learning steps and you want to use this green method, you got to remember, in this case only, we don't keep the GCF. It's just something you got to remember. Like when you're learning to read, you have to remember that that is sword. There's no reason for it. That's how we spell the word sword. You just have to know it. Okay? So then when you do that, you end up with, of course, 2x minus 1 and 6x minus 1. And you get the same answer all the way down. But you need to know what method you use. The reason I like number 3 is I think it's the one with the least amount of math, personally. But I don't like it because it makes you guys say, oh, is this the one I keep the GCF or do I get rid of the GCF? All right? You have to make that decision. I cannot make that decision for you. All I can do is show you different ways to get somewhere. You have to decide on the route. All right? And you have to decide. Okay, I say I work in all 4 of them. I don't really. Okay, I don't. This is the one I use. I do it in my head, but that's the one I use. All the time. The only time I rely on guess and check is when it's really weird numbers. Like if I had 36 and 21 on the edges, I might do some guess and checking. Everybody cool? And that's only because I don't want to multiply 36 times 21 and start going through those factors, because that'd be a big number, right? It'd be like 600 and something. Everybody good? Ellie.
I have a question. For decomposition, how do you know which numbers to take out? Because sometimes I take out the wrong ones.
Oh, okay. So what you mean is like if I gave you, let's do another one. Let's do this one, for example, by decomposition. All right? Because you're now the second person that likes decomposition, so I might as well spend a bit of time with it. So we're still going to do that. So we're still going to need to multiply to 12 and add to 3, or 8, right? And again, it's 6 and 2. So now we just rewrite 4x squared plus 6x and then plus 2x plus 3. Yeah. Now, some kids always say, well, which one do I put where? It doesn't matter, right? So then you do this, and you just work it, you GCF them. Now, if I change the order, plus 2x plus 6x plus 3, and I bracket that, what's coming out of there? 2x, right? 2x to the front, 2x plus 1. What's coming out of there? 3 plus 3, 2x plus 1. 2x plus 1, 2x plus 1, 2x plus 3, 2x plus 3, right? So the answer is, of course, 2x plus 1 and 2x plus 3. Now, if I do this one, what's coming out of here? 2x, right? to give me 2x plus 3. And what's coming out of here? Nothing. The only common factor there is 1, right? So plus 1, 2x plus 3. 2x plus 1, 2x plus 3. Okay? Everybody good? Oh. Yeah. All right. Now, I asked you, yes, everyone's cool? Everyone's got their score to 23? It's been recorded, Marcos. You can check it later. All right. I asked you to do one question. This. And we even did the first step. Now, if you weren't here yesterday, you're going to want to pay very close attention right now. So, as always, our job is to get the letter by itself, yes? Right? So we moved this over here. It became positive. Everyone's cool with that step, yeah? Everybody should have done this already. Now what bothers us? The radical sign, right? It's super easy to get rid of the radical sign. All we got to do is square that. And what's going on the left now? Absolutely. But if we square the left, what do we do to the right? Square it. And now I've got n squared plus 4n plus 4, right? Because that would be n plus 2 times n plus 2. Everyone's cool to there, yes? Now, of course, you look at that and you see there's too many letters. So, I always want my first one positive, right? We've talked about that in factoring. So, am I going to move this? No. So, I'm going to move this. What happens to that positive 6 when I move them over here? So, I'm going to have n squared and how many n's? Sorry, minus 6. How many n's? Minus 2n. And what is going to happen to that positive 19 when I move it over here? Negative 19 to give me negative 15. And what did I leave over here? 0. Now, what does that look like? It looks like a trinomial that I might be able to factor, right? Even if I hadn't told you what we were doing here in math class, if you saw that since grade 10, you'd factor it, because that's what you do when you see them. And that is, of course, what are the two numbers that multiply to 15 and add to negative 2? 3 and minus 5, right? So I have n plus 3 and n minus 5 equaling 0. Now, this is the part that even if you were here yesterday, this is where kids get screwed up. I went through it very slowly. I'll go through it again. This is one single factor, yes? How do you know it is one single factor? The brackets. This is a second factor, yes? If this is true, factor 1 times factor 2 to equal 0, what do I know about one of those two factors? Pardon me, Bea? To equal 0, one's negative and one's positive? One has to be 0, right? If factor 1 is 0, then it doesn't matter what this is. The answer is 0, right? If factor 2 is 0, then it doesn't matter what factor 1 is. The answer is going to be 0, right? So I have to check two options. I have to check n plus 3 equals 0, and I have to check n minus 5 equals 0. So if I do this one, now all of you should be seeing the pattern right now. If it's just an n, that moves over, n equals negative 3, right? If it's that moves over, n equals 5. So I now all of a sudden have two possible answers for n. It could be negative 3 or it could be 5. So then, now I have to check. Where do I check? You should check in the original equation. But our original equation has this yucky negative n here, yeah? If I move that over to this level, is it the exact same? Then it's much easier, I find, to check. Because I find that I sometimes forget, if that's already negative and that's negative, I sometimes forget to make it a positive. And I know that happens to some of you as well, right? So when I put it here, I just find it easier. Negative 3, n equals negative 3. So what is 6 times negative 3? Negative 18. What is negative 18 plus 19? 1. What is the square root of 1? 1. So when I'm doing negative 3, I get 1 on the left side, correct? What is negative 3 plus 2? Negative 1. Does 1 equal negative 1? No. So negative 3 doesn't work for us. Let's check 5. What's 6 times 5? 30. What's 30 plus 49? 30 plus 19. 49. What's the square root of 49? 7. So when I use 5, this side is 7. Agreed? What is 5 plus 7? What is 5 plus 2? 7. Does 7 equal 7? So 5 is the right answer. Now, a great many of you still are saying, Myers, how can there be 2 answers here, but only 1 answer up here? That is because we squared this. Because we remembered that the square root of 49 actually has 2 answers, plus or minus 7. Once you square something, you open us up to the possibility of 2 different answers, which is why you must check. If you don't, then you're in trouble. This right here, this that doesn't work, is what we call, and this is new note, so you want to write this down, an extraneous root. Extraneous meaning it's not necessary, because it only exists because we squared. Everybody cool? Now, it's possible, like in this question, we had an extraneous root. In this question, we had an extraneous root because 11 didn't work. In this question, we only had 1 root and it did work. It is possible for both roots to work. You don't necessarily have an extraneous root. Is everybody cool? Now, the only other thing that people were asking about were restrictions. Because sometimes you'll get 2 numbers that work in the equation, but one of them is impossible. For example, what if we were doing an equation about the speed of something, and we got negative 3 and positive 5, and they both worked in the equation? Is one of those an impossible speed? Which one? Negative 3. You can't have negative speed. So even though they both work in the equation, this one can't be, because speed would have to be greater than 0. So while this is not an extraneous root, it is a restricted root. Everybody understand? Yeah? And the restrictions are usually because anything under the radical sign, your radicand, must be greater than 0. You can't have a negative radicand, right? If we're doing square roots. If we were doing cube roots, it can be everything, right? If we were doing 4th roots, could it be negative? No. Fifth roots? Yeah, it could be everything. Sixth roots? No, because the even root means you're going to hit it has to be positive, right? So this is the restriction part. You just take anything under a radicand and make it greater than 0. And then you do the algebra. And how you do the algebra is the same way you do it if it was an equal sign. Not as important for this section. Very important in the next two. Because in the next two, we're going to be using this type of math to find answers, like in a physics class. Everybody okay? All right. So let's move along. So none of you should have any problems with E. Right? So let's try it. Go ahead, Sophia. What you've already started it?
Yeah.
What was your first move? While everybody else is thinking up their first move, tell me what your first move was.
I took the 8 over 3.
Great first move. Stop there for a moment. Everyone agree? Let's get that radical isolated, yeah? So we're going to move this over here. And I'm going to get 5a minus 5 equals, what does this negative 8 become?
5.
Plus 8, so we get 5. Is everybody happy with that first move? Cool. Would anybody like to offer what they think the second move needs to be? Square. Square what? Both sides, because we want to get rid of that radical, yes? So let's square that, and I get 5a minus 5 equals 25. Agreed? And now we're at grade 9 algebra, aren't we? 5a equals 30. A equals 6. Everybody cool? Now, is 6 guaranteed to be the right answer? It's not possible that it might be extraneous? Let's check. If I'm going to go to this line right here, because then I don't have to deal with this negative 8, right? At this line right here, what is 5 times 6? What's 30 minus 5? What's the square root of 25? So that side's 5. Does 5 equal 5? So we're good, right? Everybody happy? Let's check and make sure 5a minus 5 has to be greater than 0, yes? Right? So 5a has to be greater than positive 5, because I moved that over there, right? One sec. A has to be greater than 1. Was A greater than 1? Yeah. Now, Bea asked, do I have to do this? Well, let's check. Do I have to? Right here, we saw that it worked, didn't we? We saw that it was okay. So we're good. Now, the reason that you want to do this part, the reason we do this, if we do this first, and we find that A has to be greater than 1, and we do all of our math here, and we find, let's say, for example, that this was negative, so A would be negative 6. A has to be greater than 1. Is this greater than 1? So would we even need to check it if we got that as an answer? No. That's why we check restrictions first. Okay? So this one right here, if we check our restrictions first, then maybe we already know one of our roots or both of our roots don't work without checking. So I always like to check restrictions first, because it's a pretty easy check, right? I only look at the radicand. Negative 3m plus 10 has to be greater than 0, right? So negative 3m has to be greater than negative 10. and m has to be less than 3 1/3, because I divide that by negative 3. And when you divide by a negative, you flip the sign. That was from grade 9. I could show you why, or you could just remember that if you divide or multiply by a negative, you have to flip the sign. Everybody cool? So now let's say at the end of all this work, we get m equals 2 and m equals 5. Do I even need to check 5? Why not, Marcos? Because the answer has to be less than 3 1/3, right? So 5 would be no good. I don't even need to check it. Does everybody see? Everybody understand why we check our restrictions? All right, so let's have a look at F. Let's do this thing. You guys start working on that, because there's something that I forgot to put in your notes that is bothersome to me. And it makes me feel like I'm an idiot. And I'm not. I'm a pretty smart guy. So I got to fix this. Yes, please do. Okay, so what are we doing first? We're going to bring over the 4, and then we're going to rewrite. Everybody happy with the first step? Okay, then what? Square both sides. Now remember, let's not think about the steps. Let's think about why we're doing them. Why am I squaring both sides? What is my goal? To get rid of the radical sign, right? So that's going to get me negative 3m plus 10 equals, and I'm just going to do this in my head, m squared minus 8m plus 16. Everybody's cool with that, right? Right? Maybe you need to write out the FOIL and actually do it, but hopefully by now you're starting to see how these work. You add them to get that term, you multiply them to get that term. Everybody good? Now what bothers us? I got too many variables, so I got to collect my like terms. Should I move that? I should move the negative 3. I don't want to move everything to the left. Even though that's the way we like to see equations written, isn't it? We like to see 2x plus 7 equals 14, don't we? That's what we like to see. But it's no different to write it this way. Why do I want to keep that m positive? Again, this is like, everybody agrees we're not moving the m, but why? What's easier to factor? Negative m squared plus 7m plus 12, or m squared minus 7m minus 12. Which one is easier to factor? The bottom one. So, like I was saying when we were doing our GCF, you want to keep this term positive because it makes it easier later on. So we're going to move everything over here. What is the right side of my equation going to look like? M squared minus 5m plus 6 equals 0. And now that looks like something you've done to death. What do I do every time I see that type of trinomial? What do I try to do? What do we try to do when we see that type of trinomial? Factor it. I have to multiply to what? And add to what? What is it? -2 and -3. And now, just by looking at that, what is m? What does m have to be? +2 or +3. Are both of those numbers less than 3 1/3? Yes. So because they're both less, we have to check both of them. Right? Now, we can check in this first line here because all we did was move that 4. I think this one is easier to check than this one, but you can check anywhere you want, right? As long as the root is still there. You have to check in one of your lines that has the radical sign. So, what's -3 times 2? What's -6 plus 10? 4. What's the square root of 4? +2. Everyone agree? So when I check this guy, I get +2 on the left. Yeah? What is 2 minus 4? -2. Does 2 equal -2? Nowhere in my universe. So this guy's dead to us. Let's check 3. What's -3 times 3? -9. What is -9 plus 10? 1. What is the square root of 1?
Sorry, 1.
What is 3 minus 4? -1. Does 1 equal -1? Not in my universe. Holy crap. So what does that mean? Does this equation exist? Does it have an answer? No. There is no number that makes this true. Does everybody understand? Yeah? Okay. What makes G more difficult? There's 2 different radicals. I want you to take a moment and have a look at that. Talk to your neighbor. You needn't write anything down. See if you can think of something to do with that. I don't want to poison your mind, so I'm going to let